Hello, hello, and welcome to this video on Rust programming. So we have more or less covered a major portion of the language side of Rust. So we'll now see some common practical stuff. I know we have not yet covered multi-threading and we have not covered native programming, but those will be put on hold. Now we will go through common stuff and standard library. So starting with this video, in this video I'm going to talk about keyboard input and file input output because both are very common things which you need to do. I could have covered this earlier, but it's all right. So better late than never. So this video we will talk about keyboard input and file input output. So let's get started. So this program is about keyboard input output, this particular one. Then we will look at three file input output programs. So the main module is stdio and we import write. So to take input, keyboard input specifically, we need a string, okay? And once we have our string, we print, type something. This is not println. You can use println as well. And after that, we flush the standard output. Now there are three file descriptors usually associated with terminals or consoles. One is stdout, standard output. That is the file descriptor number one. I think one is input. I will see. One or two is input or output, so they are exchangeable. The second is standard in called stdin, and the third is stdr, standard error. So we flush the standard output file descriptor, and this will ensure that this string is written, and then we read a line. So this read line function is called on standard input object of IO module. And in this we pass the string. This string will be used to hold the data coming in from the keyboard. So that's why it needs to be mutable, and we send a reference. Okay. Now if there is some error in reading the line, then we say fail to read user input. Once we receive the input, there is a \n character which is from the enter key of keyboard input. So we trim this. So that \n is removed. In general, trimming is a good idea so as to remove the white space if there is any from the left and right side both. Once we have that, we have our input in the clean input string. Okay. Now optionally, what you can do is, suppose you want to take input like an integer or a float. Okay. Then you need to parse that. So we don't need to trim it here again. Okay. So we need to parse. Now parsing may pass or fail. For example, you want a number, but the user mistyped something which is non-numeric character. Or you might want to parse for integer, but user by mistake entered a float or some invalid character. So this parse returns a result a num. So if it is okay, we have the number. If it is error, you do the error recovery process. So let's see this in action. Okay, we have terminal panel and we say cargo run, and it prints that please type something, and we can print say 42, and we have a number. You enter 42, input is 42 because we printed twice, clean input once as a string and then as a number. So if you want to pass here as float 32 or float 64 or character or U8, you can give that here. So that was about our keyboard input. Okay, output is simple. Println we have seen for many times. Now another is file input output. So file input output, the first thing we should know is that you need first to open a file. To open a file, you need its path. Path means what directory it lies in. For example, this hello.txt should lie in current directory, and then we have a display path.display function, So for this, the main stuff you need is fs file, then we have IO prelude, and we have path. Now we display the path, and we don't display, we create a variable display, and then we have the open stuff. In open, you give the path as a reference, okay? And then we have, if we have error, then we say why the error has come, and we panic. Panic means we print the message and just crash the program. If okay, then we have file. In the file descriptor, not file, okay? This will be our, not descriptor, handler. Then we create a string new, and we read the file to read to string as mutable string. And if there is an error, we say that couldn't read, and in case of okay, we say that it contains the string s. Okay, we don't need to close the file, because if it goes out of scope, then the file will be automatically closed, because Rust is based on RAI. So as soon as the file variable goes out of scope, that is this variable, the file will be closed, and file handles and all will be closed. So we go to file IO1, and we create a file, hello.txt, because that is what we need. Hello world, we put it inside hello.txt. Now this might fail. I have not run this. This might fail because hello.txt is not in the same directory as the binary, but it might work. So we say cargo run, and it did pick up our hello.txt file, and it says hello.txt contains hello world. Now why open could fail is, one of the reasons why open file can fail is if you don't have read permissions. For example, I can do chmod 000 on hello.txt, and if you look at the file now, ls-l hello.txt, you don't have any permissions on this, okay? And if you do cargo run again, it says, well, permission denied. You see, couldn't open hello.txt, and it tells the error, permission denied. So one of the common reasons why a file is not readable is permissions, or the other thing could be that it is ownership issue. So if you look at hello.txt, it is used, owned by Shiv, and group is also Shiv, and for others permission is read. For Shiv group it is read, and for Shiv it is read write. So you should look at the ownership and the permission of the file. Now that is the OS specific thing, and on Linux you should know what are ownership and permissions of a file. Now we look at the second program, that is this one. Okay. So we have a static string lorem ipsum, and we use the same three stuff. So this is static string we will use to put inside a file. So again we create the path variable, and then this time we create a file. Now to create a file, you need to have write permission in the folder which you have. Okay. So I'll show you in a bit. Okay. So if it can't create a file, it will panic. If it can create a file, it will create the file and give us the file handler. And then we write lorem ipsum as bytes. Okay. And the function to invoke is write all. So for example, now we go to file IO2, and the current directory which I'm talking about is ls-l, rather you need all. So this dot directory which you see, or any directory which you need, for example this will be current directory, you need write permission over here for the user you are operating on. Again it is user and group. So RWX means, first RWX means I have permission for read, write and execute. So I can do this, and I run this, and it wrote to lorem ipsum.txt. When we run, we see the cat lorem ipsum.txt, and we have the contents here. Okay, so pretty easy. Now we look at the third program. Now this is how we can read a file line by line. So if you saw our first program, it is not very good. Read to string will take the entire contents of file into the mutable string s. That means it will consume a lot of RAM. So to read a file efficiently, we will do some trick. Okay. So what we do is we call a function the read lines.txt, we make this, oh fine, let it be there, okay. So what this function does is it receives a file name, it returns a result which contains the lines, which contains the buff reader file, okay, we call buff reader. So here it will open the file and we return a buff reader object, and then on that we invoke lines. So we return this lines object. All right. So buff reader will not read all the file in one go. Okay. So it will returns an iterator, and we iterate on that line and we map while the result of this iterator is okay. Upon reaching the end of file, which is called EOF character. In C library, the EOF character is hard coded as -1. Okay, it is not a valid character. Usually you do that with Control D. In files you don't need to do that, but if you have to give an EOF character on terminal, we say Control D. That is the EOF character. So we run this program and see how this works. So this will be much more efficient than this program, file IO1. It won't load the entire file in memory, and it will read only one line at a time. It will hold only line variable in the RAM. So we go to file IO3 and we need a file host.txt. So we say echo hello1 \n hello2 slash not slash host.txt, and we look at host.txt. We have, okay, we didn't get 2 lines, so we forcefully make it. All right, now we have 2 lines, and we save and exit, and then we say cargo run, and we have 2 lines. So this file, when it will be read, those 2 lines will come separately into RAM, not at the same time. So if you have to read really large file, you can make use of this. For small files, this will work nicely. Okay. So I think with this, I will stop this video here, and we have not done any binary file reading writing. So those are special things. This should work mostly for your normal files. Okay. Now writing could be multiple stuff, but this will work for now. So you can write more stuff into files. There are lots of stuff. If you look at, for example, I don't know why Rust Analyzer is not getting it. I'll show you in the next video what this file module contains. Okay, and we'll go through the functions of this file, and we'll see how it facilitates various different kinds of input-output stuff. Okay. And similarly, we will go at the IO, there is buff read, and we will look at stdio module. So in the next video, we will discuss the file module and IO module, and we'll go through a bit of documentation, and we'll look at these 2 modules in detail. So with this, I will end this video here, and I hope that you are enjoying this series of videos and finding it useful for learning Rust. So thank you for watching the video, and I hope that you keep learning, and we will meet again after say 4 days to learn another to have another video on Rust and learn more. So once again, thanks a lot for watching. I will take my leave. You have a nice day and enjoy.